notes 10.2, Pythagorean theorem. It says solve following equations. So when we solve equations, okay, you learned this way back when we first started solving equations. If we were adding something, how did we undo addition? Subtraction, okay, and it went both ways. Okay, if we had subtraction, we undid it by addition. If we have multiplication, how do we undo multiplication? Division, and again, that works both ways. Now, yesterday, we brought in a third set of inverses to undo things. So we have been working, when we square things, yeah, that's not the best representation of it, but that's okay, we'll work with it. When we square something, to undo squaring, what do we do? What's up? Square rooting, okay? Square rooting, okay, and vice versa. To undo square rooting, we square things. So this is another set of inverses that you need to have in your mind when you're solving equations. So if I need to solve for x, and this first one says x squared equals 16, how do I undo something squared? What we just said at the top. How do you undo something squared? Square root it. So whatever you do to one side, you have to do to the other side. Just like normal. So if I just undid that x squared, it just becomes x. Now we have to think for a second, what is the square root of 16? That was easy. It's 4. Because a number times itself gives you 16. 4 times 4 gives you 16. But there's also another number times itself that would give you a positive 16. What is it? There we go. Where is it? X equals 4, which that was the easy one to come up with. 4 times 4 gives you 16. And then Rodrigo said, well, what about, he said negative 4. Because negative 4 times negative 4 also gives you positive 16. 2 answers to that equation. Okay? Generally, what happens is, okay, if your exponent is 2, you're going to have 2 answers. If your exponent is 3 for your x, how many answers do you think you're going to have? 3. Your exponent is 4, you're going to have 4 answers. Okay, so that's kind of a little reminder. So in number 2, a squared equals 9. Who can tell me what my 2 answers should be? Caitlin. 3 and negative 3, because we take the square root and we get a equals 3 and a equals negative 3. Now, as mathematicians, we like shortcuts. So you can write those 2 answers like this. You can say a is equal to plus and minus 3. You kind of stack the plus and the minus over each other, okay, to get that 3. Some of you totally just checked out with that, and you're going to see that later on, and you're like, what's that? What is that? As a little reminder for those of you that were just checking out. Negative and positive 3, plus and minus 3. You can write it either way. All right, so let's talk right triangles. So what is the definition of a right triangle? It's a triangle with one right angle. Our angle symbol is that less than symbol with sort of a little half circle through it. And that drawing that's there, you guys have to put that there. I already have my triangle drawn. To indicate that there's a right angle, you put that little box where there's the right angle. And then we have some parts to the right triangle. The 2 sides that make up the right angle are called the legs. So that's a leg and that's a leg, because those 2 sides make up that right angle. And then we have a special name for the other side that's across from the right angle, and that's called the hypotenuse. Right? Hypotenuse. Okay? But the thing is, with that hypotenuse, you got to be careful. It is the one that's always across from the right angle. Because the legs make up the right angle. The hypotenuse is the one that's across from the right angle. Okay? Now it says, in order for a triangle to be a right triangle, it has to satisfy the following equation. Now this is pretty easy to remember. A squared plus b squared equals c squared. Okay? Or a to the second plus b to the second equals c to the second. And this is called the Pythagorean theorem. Now what's the A, what's the B, and what's the C? So just back up in our right triangle drawing, A is a leg, B is the other leg of the right triangle, and C is always the hypotenuse. And that is critically important to know. So if A is a leg and B is a leg, does it matter which one goes where? Which leg goes where in the Pythagorean theorem? Why not? What's the operation between the two? Addition. So does it matter if I say 3 plus 2 or 2 plus 3? No, it's the same thing. So the legs don't matter where you put them in either A or B. The one that's important is the C, the hypotenuse. So it says here, indicate whether the following are right triangles. So these are sides. 3, 4, and 5 are sides of potentially a right triangle. We want to see, are they truly sides of a right triangle? So right here, okay, in order for a triangle to be right, we said it has to make this equation true. A squared plus b squared equals c squared. So how do I know which one is C? You said the legs didn't matter. How do I know which one is C? The 3, the 4, or the 5? Yeah. The largest number is always the hypotenuse. So let's go back up and put that back on our picture. Okay? So the hypotenuse is always the largest side. Always the largest side. And the legs are the other two. Now I happen to put these in order, 3, 4, and 5, chronological order. Don't always just pick the last one in line. Because if the sides aren't put in chronological order, you're going to make a mistake. Always make sure you're picking the largest side to put in the C spot. So we'd say leg squared plus the other leg squared equals the hypotenuse squared. And I might put a question mark over that, equal sign. Because you got to see, is this true? So what is 3 squared? Anybody? 9 plus 16. Does that equal 5 squared, which is 25? Does 9 plus 16 equal 25? Yeah. True. So are 3, 4, and 5 sides of a right triangle? Yeah. Because it made the Pythagorean theorem true. What about 5, 7, 13? Which one's the hypotenuse? 13. So leg squared plus the other leg squared equals the largest one, or the hypotenuse squared. So what is 5 squared plus 7 squared? 45 plus 49. Does that equal 169? No. Does not equal. False. Okay. So are 5, 7, and 13 the sides of a right triangle? No. What about number 5? 3 square root of 27, 6. I don't know what the square root of 27 is approximately. Type that into your calculator right now. And I said approximately. This is irrational. square root of 27, roughly, Caitlin, is what? 5.19. Okay. So square root of 27 is roughly 5.19. So which one is my hypotenuse?
Sorry, I had a question.
Go ahead. 6 is the hypotenuse.
No, sorry, 27.
It's the square root of 27. We just said it was 5.19. So 6 is my hypotenuse. Okay, 6 is the biggest. Okay. Now, let's go ahead and substitute that in. 3 squared plus, now I'm going to put the square root of 27 in parentheses to square it. And we said that 6 is my largest. So what is 3 squared? 9 plus. Now, what happens to the square root of 27 squared? What does that equal? Use your calculator. Type it in exactly the way I've written it up here. Or, yeah, think about squaring and square rooting. They undo each other, so you're just left with 27. It's not the biggest number. The square root of 27, we said, was 5.19. Okay? Equals, and then 6 squared is 36. Does 9 plus 27 give you 36? True. Yep. That is, those are the sides of the right triangle. What about 2, 4, and 9? So 2 squared plus 4 squared. My largest one is 9. So I end up with 4 plus 16. Does that equal 81? No. Nope. False. Can't be the sides of a right triangle. All right, let's fill in the missing piece. 5, 12. Here's my right angle. So that's my hypotenuse. That's my C. Yeah, just put it in. Yep, if it's not on your paper, go ahead. Fill it in. So who can substitute these numbers into my Pythagorean theorem?
5 squared plus 12 squared equals x.
X what? Squared. So now we're going to solve it. What's 5 squared? You know it is 25 plus 44 equals x squared. So now combine like terms. What's 25 plus 144? 169 equals x squared. How do I undo that? How do I undo x squared? Square root it. X equals what? 13. Do I need to think about the negative 13 that's a possible answer here? Why not? There'd be a reason why not. Why wouldn't I think about negative 13 for my hypotenuse? Yeah, sides can be negative. Okay, we're talking about a shape here. Right? So just one answer is true here. Go ahead, flip it. Number 8, who can substitute in for me for 8? Danny, go ahead, substitute. Yep, and right into the equation.
1, 2, 3 plus x.
Just x or x? Yeah. Huh? And we got to say the square root of 17 in parentheses, like you said, square it. Yeah, lots to write for the hypotenuse there. Okay, how did we know that 17 was the hypotenuse? There's the right angle, whatever is across from it. So 1 squared is just 1 plus x squared equals the square root of 17 squared. Quick, is just what? 17. How do I solve that equation? Joe? Not yet.
This 1 plus
something. True. Well, what are mathematically or algebraically, what step do I need to take first to get x squared by itself? Subtract the 1. and I get x squared equals 16. Now, how do I undo something squared? I square root it. And what is the leg of that triangle? 4. 4. Number 9. Who can substitute for number 9 for me? Go ahead, Matt.
The square root of 32 squared.
In parentheses, squared, yeah.
Squared plus 3 squared equals x squared.
Yeah. Because here's my right angle, so what's across from it is x. That has to be my hypotenuse. So the square root of 32 squared is what, everybody? 32. Okay, that clearly wasn't everybody. I heard like 3 voices. Okay. Plus 9 equals x squared. 32 plus 9. Thank you. 41. Selena, I like the quick math. The square root, is 41 perfect? No. Can I simplify 41? We did yesterday in class. Is there a perfect square that is divisible by, is 41 is divisible by? Does 4 go into 41 evenly? No. Does 9 go into 41 evenly? 16? No. What do we know about 41? It's true, it's an odd number, but even more importantly, it's a thing. Oh, what? No, wait a minute. Let's do 10, 17. Let's do 10, 17. I think that's 51. That's 51? Oh, okay. All right. I think we're looking at a prime number here. So, 40, square root of 41. That's our final answer. Can't simplify it. That's my hypotenuse. Okay. Last one. We got to draw a picture. Okay. A 5-foot ladder rests against a 4-foot vertical wall. Okay, think about what that looks like. Okay, you got a wall, and you have a ladder leaning up against it. Visualize that. Okay, somebody's got to be able to climb up that ladder. Okay, and you can assume, okay, that vertical wall is nice and perpendicular. Okay, or forms a right angle with the ground. Okay. So here's my wall, here's the ground, and then in order for somebody to climb up that ladder, okay, it's got to be at a little bit of an angle. Okay, so that's our ladder. So the ladder is the hypotenuse. So we have to label, it says a 5-foot ladder. So the hypotenuse is 5, resting against a 4-foot vertical wall. How far away from the wall is the ladder? So we're looking for that piece right there. Looking for the X. Okay? Or one of the legs of the triangle. Who can substitute for that? Caitlin, go ahead. Excellent. Okay, she made sure that the 5 was in the C spot. So we have 16 plus x squared equals 25. To get x squared by itself, I got to subtract 16. 25 minus 16 is 9. Now what? Got to get x by itself. Square root it. Nice. I like you guys using that terminology. X is equal to 3. All right. We're done.